Welcome to this video on adding and subtracting rational expressions, where both expressions have the same denominator. First, let's review how to add fractions. So what does a fraction mean? If you have 1/3, what does that mean? Well, what it means is that you have one whole that has been divided into 3 equal parts. 1, 2, 3. Then the numerator, means that you have one of those 3 pieces. So literally you have 1/3 of something. So if I have 1/3 plus 2/3, how do I do that math? Well, both pieces remain divided into 3 equal sections, so the denominators stay the same. We do not add them or change them in any way. So we have 1 piece in the first pie, 2 pieces in the second pie. That's a total of 3 pieces. You can see visually that we have 3/3 in the third image there. So, of course, we can always reduce fractions, and we should reduce fractions when we can. So 3 divided by 3 would just be 1. And again, that agrees with the picture. We have one whole pie shaded based on the picture. So how does this concept relate when we start using algebra and start introducing variables? Well, let's use this first example. So again, just like in the last example, we have the same denominator. So our process is going to be exactly the same. We are going to add the numerators while keeping the denominator the same. If I go back here, another way I could have done this or rewritten it before I finally got the right answer is I could rewrite 1/3 plus 2/3. I could rewrite that as 1 plus 2 all over 3. Of course, 1 plus 2 is 3. And notice in this process, we still get the same exact answer. So this writing the sum of the numerators in over 3, writing that as a single numerator and a single denominator, is sort of an intermediary step, and that's what we're going to do in this next example. Again, hopefully you can see 1 plus 2 over 3 is the same as 1/3 plus 2/3. Okay? So again, we're going to rewrite this all as a single expression over the same denominator. Okay, so we're going to have x minus 4 plus x plus 8. Okay, and again, we're going to put it all over the single denominator, which is x squared minus 2x minus 8. Okay, and if this is confusing you in any way, just remember, you really can. You can rewrite 1/3 plus 2/3. You can rewrite that as you can rewrite it as 1 plus 2 over 3, or 3 over 3. This is a legal mathematical operation. We're doing the same thing here. We just happen to have variables. Okay? So you can do this any way you want. What I like to do is I like to group my like terms. So I have an x here and an x here. So I have x plus x. I like to put them next to each other so that I can see that they are like terms. Then I will put the constants next to each other, again, because I can see that they are like terms. Okay, so let's go ahead and do some math. So we have 1x plus 1x, right? Remember, you can always put a 1 here. So 1x plus 1x is 2x, okay? And then we also have negative 4 plus 8. Negative 4 plus 8 is positive 4, okay? And of course, nothing at all is happening downstairs in our denominator. It stays exactly the same, okay? So I have 2x plus 4 over x squared minus 2x minus 8. Okay? But remember, in our example here, right, with 3 over 3, we needed to reduce it. So you might think, oh my gosh, this is definitely the final answer. I'm done. I've added my numerators. Okay? But we always want to see if we can reduce. And remember, when we're working with polynomials, the way we might be able to reduce them is by factoring. Okay, so we're going to pull everything we learned about factoring polynomials in order to potentially, maybe, reduce this fraction. Okay, so let's look at first the numerator. We have 2x plus 4. So remember our general factoring strategy. Our general factoring strategy is first we look for the GCF. What is the GCF in the numerator? Well, the GCF is 2. If I factor out a 2, I'm left with 2 times the quantity x plus 2. Okay. Remember, if you're uncertain or unsure about any of this process, you can always go back and distribute, right? And then when I would multiply that, I would be back to 2x plus 4. Okay. So of course that's not really going to help us. We're trying to factor, not expand. But I just want to remind you, you can always use that. Okay, so what is the next step after the GCF? Well, the next step is we ask ourselves, how many terms do we have? Okay, and in the numerator, we're done. There's nothing else that we can factor. But if we look at the denominator, well, the GCF of these three terms is 1. However, we have 3 terms, so we're going to try to use the AC method. So the AC method says that we need 2 numbers that multiply up to -8 and add up to -2. Okay, you can do some trial and error here, but the bottom line is that you're going to have -4 times +2. That's going to multiply up to -8. -4 plus 2 gives you a sum of -2. Okay. Also, we can use the shortcut method here. So our factorization is going to be x minus 4 times x plus 2. Okay. Now, if you need a review of a factorization, I have a whole set of videos on just how to factor polynomials, and it goes over this general factoring strategy that I mentioned. So if you need that review, please go watch those videos. Okay, so examining this expression here, you can see it's a really good thing that we took the time to factor things, because we do in fact have terms in the numerator and the denominator that can get canceled. Okay, I also want to remind you, I've been trying to enforce this throughout the whole chapter, that we have these restricted values. Okay, now the textbook might not enforce this in every section, but it's really important, and you'll see why as you progress in your math career, to remember that you still have restricted or excluded values. Okay, if we make this a function of x, we set this equal to f of x, or set it equal to y, and then we graph it. Okay, the behavior of the function is going to be different at x equals -2, even if we cancel out the numerator and the denominator. Okay, so remember, these restricted or excluded values come from when we try to set the denominator equal to 0. Remember, we can't divide by 0. So we have to say that x minus 4 cannot be equal to 0, and we need to say that x plus 2 cannot be equal to 0. Therefore, our restricted values are +4 and -2. Okay, and again, even if it's beyond the scope of the textbook, I still want you to think about and list these excluded or restricted values whenever you do this. Okay, so the fun part here, right, we get to cancel those out, and then we get to write our reduced expression. So we have 2 over x, x minus 4, okay, but again, the textbook would leave it like this. I myself personally am making a note here that we need to write x cannot be equal to 4 or -2. Okay, so this whole thing, okay, including the restricted values, would be my final answer. Okay, all right, let's do another example. So again here, we can look at this and we can see that our denominators are the same. Okay, so just as before, right, if we have like 1/3 plus 2/3, we can just rewrite it as the sum over a single denominator. We can add those, and then of course we have to reduce. Okay, so let's go ahead and do that. So we're going to write 5x minus 12 plus 14x minus 6, okay, and that's all going over this single denominator of 3x minus 6. Okay, I'm going to take an extra step here, and I'm going to take some time to rearrange my terms so that like terms are next to each other. Okay, and then I'm going to combine my like terms. So 5 plus 14 is 19, so I have 19x. -12 minus 6 is -18, so I have 19x minus 18 over 3x minus 6. Okay. So let's just stare at this for a second, look at it, see, make sure we didn't make any mistakes, and make sure we added everything correctly. Okay? So remember, you always want to try to reduce, and you reduce by first factoring both numerator and denominator. So is there anything that we can factor here? Well, it looks like we can factor the denominator. We could factor out a 3. So I could rewrite the denominator as 3 times the quantity x minus 2. Okay, but upstairs I still have 19x minus 18. Okay, and it doesn't look like I can do much with the numerator. So really, this is my final answer. There's really not anything else that I can do. Now, I still want to remind you of your restricted or excluded values. Okay, I used the term restricted and excluded interchangeably. So remember, we cannot divide by 0, so x cannot be equal to 2. Okay, so we'll make a note of that right here. So this will be our final answer. And again, because you can't do anything with it, you cannot reduce it if you were to give this as a final answer as well, without the factoring out the 3. I think that would be okay because, again, factoring out the 3 isn't getting you any closer to your solution.